Hello and welcome to the fifth session under Unit 3. In this session, we'll be looking at the synthesis of alcohol. So, at the end of the session, you should be able to learn about how to produce, or you should be able to even produce cyclohexene through the acid catalyzed elimination of water from cyclohexanol. Okay, so there are basically about four chemical reactions in organic chemistry. We have the combination, we have the elimination, we have the substitution, and then the rearrangement. And the dehydration of alcohols to form the alkenes, so is a typical example of an elimination reaction. And the common catalysts that can be used are the strong mineral acids such as sulfuric acid and then phosphoric acid. Now, the mechanism of the reaction involves three major steps. The first step is the protonation step. The second is the cleavage of the CO bond, and then which leads to the elimination of water because water is a good living group. It leaves, and then the last is the deprotonation by a base to form the carbon-carbon adjacent bond that forms from the carbocation intermediates leading to the formation of our double bond. So we have the protonation, the cleavage of the carbon oxygen bond leading to the removal of water, and then the intermediate carbocation that is formed has to undergo deprotonation by a base to form our resulting alkene, right? Okay, so in this experiment, you look at, or you are going to dehydrate an alcohol, in this case cyclohexanol, to form cyclohexene. Now, the choice of cyclohexanol as the starting material is based on the following consideration. Because its structure, because of its structure, cyclohexene can give only one alkene upon dehydration, right? So, based on this structure, the only product that is formed is cyclohexene, and there are no other side products or byproducts that are formed in the process. So only one product is formed. The rate of the dehydration of the cyclohexanol using 80% phosphoric acid is conveniently fast. So that's also another consideration. And lastly, the product is easily purified by distillation at a readily accessible temperature. So the resulting product and then the starting material have considerably different boiling points, and because of that we can use simple distillation to separate our products from our starting material. Material from the starting material. So mix the contents thoroughly by swirling before connecting the flask to the distillation setup, and add about some few boiling chips so that it will help with gentle heating. And then, so you are going to distill this for a while, and then you have to know that you shouldn't have to distill to dryness. So when the distillation process goes on until you have about 2 ml of the starting material in your round bottom flask, and then you can turn off the the heat source, or you can dismantle the setup. Now, what you have to know is that the distillate in the receiving flask consists of two layers. So you have your starting material and then your product. So you transfer this into a separatory funnel and add 2 ml of saturated sodium chloride solution. This is purposely to decrease the solubility of the cyclohexene in the water layer, so that more of your cyclohexene, which is the product, will move into the organic layer so that you can easily drain it off. So you add dropwise sodium bicarbonate solution. This is purposely to neutralize the traces of any remaining unreacted acid. Then you swirl and shake the mixture gently, allow the layers to separate, and then you drain off and discard the lower layer. So the lower layer is your the aqueous layer, and the organic layer is the upper layer. So you pour the upper layer, which in this case will be your cyclohexene, out of the separatory funnel, and then you allow it to dry. So the product should be very clear, not cloudy. So this is our product, our cyclohexane, and this was the starting material, which was the cloudy solution, which is the aqueous layer we don't want. Okay, so afterwards you can use the cold potassium permanganate test, which is also known as the Bayer test, to test for the product you have as to whether it's actually the cyclohexane. And then you can also use, so here you can use this uh, potassium permanganate test, where purple solution loses color with alkene and then forms manganese dioxide, which is a brown precipitate. So this is um, a negative test result. This is a positive test result. So getting this indicates the presence of your unsaturated functional group, which is a double bond. And then also you can also use another test, which is the bromine in water test. So the bromine in water test as well, we've talked about this quite a number of times. So the bromine will react with the alkene group, and this color, the orange um, color of your bromine in water reagent, so indicating the presence of the double bond. So after adding this a negative test result, this is a positive test result. Okay, so these are pre-lab questions that need to be addressed before starting the report writing, and this is just included to help you with your work. So you draw the structure, name or draw the structure, whichever is appropriate of each of the following compounds. So these compounds, you need to draw their structures, and you have to, if 1.0.13 gram of cyclohexane was obtained from 0.240 gram of cyclohexane, or what is the percentage yield? So you should be able to calculate percentage yield, and what's the purpose of adding these reagents in the process of the experiment. What do they do? You have dehydration of two alcohols lead to the preparation of methyl cyclohexane. Write the chemical equation for both reactions. And what alkenes or alkenes, what alkene or alkene will be produced when each of the following alcohol is dehydrated. So these are pre-lab questions you should be able to answer. And these are the post-lab questions as well. These ones need to be addressed before submitting your report.